Well, the moment has finally arrived. Yes, I'm going to exclusively reveal the Project Scorpio specs in this video. But first of all, I want to emphasize how kind of unprecedented this all is. Now, usually I find out about new console specs from industry contacts, but this time, Microsoft actually invited me out to its Redmond campus to meet the architects of the system, to talk through the specs and to get the whole story there. Now, bearing in mind that Scorpio is going to be a Q4 console release, this is really early. In all of my years in the business, I've never seen anything like it. So let's talk about the heart of the system, the Scorpio engine as it's known. This is the SoC, system on chip, at the heart of the console that contains all of the core hardware: CPU, GPU, memory controllers, audio block, and audio video media processors. And well, here it is in person. And well, this is actually an early production chip straight off the production line, a really nice memento from my trip. It's a 16nm FinFET chip produced by the giant TSMC. So about 360mm square with 7 billion transistors. Okay, so let's talk specifics here, and we'll start with one of the biggest points of controversy in the current gen console designs: the CPU. Now, back when I did my Scorpio spec analysis in the wake of its E3 teaser last year, I pegged the new console as retaining the same Jaguar cores as the Xbox One, but with an upclock in place. Mainly because the Scorpio engine would already be big owing to the large GPU size, and also because, well, Microsoft promised 8 CPU cores, which sort of rules out anything else. Plenty of speculation surrounded a Ryzen implementation, which I always thought unlikely, but the truth is, well, actually a little bit more complicated. Now, strictly speaking, you could say that I got it right. Scorpio does indeed use an evolved version of the Jaguar core. Just like Xbox One, there are 2 quad-core clusters there, with a total of 4 megabytes of L2 cache, and frequency has been upgraded from 1.75 GHz to 2.3 GHz. That's a 31% uplift. Microsoft, though, has targeted optimizations at the silicon level, aimed at improving coherency between CPU and GPU, and it has targeted lower latency as a priority. Now, if the processor cores can't access data from memory owing to bottlenecks in the pipeline, it effectively stalls. So increased frequency and lower latency are key to the custom CPU improvements here. But there is more. Now, at the front end of the GPU sits the command processor, which kind of takes the instructions from the CPU and, well, processes them. And here's where things get really interesting. Microsoft's engineers have effectively made a hardware implementation of DirectX 12 integrated directly into the GPU command processor. Draw call instructions on the CPU that would typically require thousands of instructions are now reduced to just 11. Yes, 11. State changes that are also heavy on CPU are now cut down to just 9. Microsoft tells me that this custom hardware alteration should drop CPU rendering workload by half on titles built on DX12 renderers. Games like Star Wars Battlefront, Battlefield 1, Gears of War 4, and the latest Forza titles, for example. Audio processing can be CPU intensive too, and this can also be offloaded to the dedicated silicon on the Scorpio engine. Well, the APB, as it's called, the audio processing block, is actually the same core hardware as that found in Xbox One. Now, here's some good news. Spatial audio in the form of Dolby Atmos and Dolby Atmos for headphones is going to be supported for Scorpio, effectively adding a height component to 7.1 surround. As the silicon is unchanged, all Xbox owners, whether you're using the original one, the One S, or indeed Scorpio, will benefit from this upgrade. Next up, let's talk GPU. Okay, so last year Microsoft promised us 6 teraflop graphics hardware, a huge upgrade over Xbox One's 1.31 teraflops, and even an impressive boost over PS4 Pro's 4.2, effectively meaning complete Scorpio dominance over all key parts of the processing specification. Now, I can confirm that 6TF has been delivered, no more, no less, but how they've done it is nothing short of remarkable. Now, regular viewers may recall that I came up with the notion of a very large GPU with 56 or 60 AMD compute units running at fairly slow clocks, based on the kind of constraints we've seen on Xbox One, PS4, and of course the Pro. The truth is, Microsoft has broken free of those constraints in ways I'm not sure anybody could have anticipated, certainly not me. So to cut to the chase, Scorpio only has 40 compute units, but these are clocked very, very highly, 1172 MHz to be precise. That's up against 853 MHz on the OG Xbox One and 911 on PS4 Pro. So compared to the new Sony console, that's an additional 11% of Radeon hardware, but a 27% boost to frequency. Combined, this gives Scorpio a 43% compute advantage. Next up, memory. Lots of controversy here when Microsoft promised bandwidth in the region of 320 GB per second. Would they use GDDR5? Would they go for faster G5X? Would we see a continuation of ESRAM? Well, back in the original specs reveal, we thought Microsoft would opt for a 384-bit memory interface paired with 12 modules of GDDR5. I mean, you could actually see it on the motherboard render that Microsoft put out last year, and that's a render that turned out to be pretty close to final hardware. So, what's the score here? Pretty much what we thought actually. 6.8 GHz G5 modules on a 384-bit interface, 12 of those modules in total, offering up a grand total of 326 GB of bandwidth. 8 gigs of the 12 total is available to game makers, up against 5 on the original Xbox One. So that's a 60% boost in available memory for games. However, system reservation has also gone up. It's increased by 1 GB to 4 gigs. So Scorpio's dashboard, well, now that can render at native 4K, something that wasn't possible on Xbox One S. Okay, so Microsoft has delivered, or indeed over-delivered, on all promises thus far. But part of the reason I was invited to their HQ to talk to the people who made Scorpio was to understand that this is more than just a collection of off-the-shelf AMD parts. There's customization here. Deep customization, and a lot of it. So Scorpio is a mid-gen refresh, right? This actually gave the development team a key advantage they've never had before. They could profile existing Xbox One games, see where the bottlenecks were on the existing hardware, and before any silicon was even fabricated, they could use hardware emulators to see how this game code actually performed. And then from there, they could rebalance the hardware to achieve optimal performance. And more than that, once they had that final balance, they could actually customize key areas of the GPU to eliminate engine, game-specific bottlenecks. In fact, I'm told that there are around 60 specific targeted customizations throughout the GPU pipeline. Again, this is unprecedented. Hardware usually defines software, but this time the Microsoft team could approach things from the other direction, optimizing the silicon based on the way that game engines and game developers are actually creating their games. The question is, would this pay off? I mean, we were promised native 4K gaming here, something you wouldn't really expect in the PC space from a 6 teraflop GPU. Well, here's Forza Motorsport 6 running on Xbox One. It's 1080p, 60 frames per second, and pretty much one of the best looking games available for the system. Back in mid-January, production parts for Project Scorpio started to arrive at Microsoft HQ. These were cobbled together at Turn 10 Studio down the road into something that sort of resembled an early prototype console. The Forza engine was ported to Scorpio in just 2 days. And, well, straight off the bat, it worked. It worked just out of the gate, something that blew the Turn 10 tech team away. Something that generally just doesn't tend to happen this quickly. And not only did it just work, but it was fast, brutally fast, without the benefit of any platform-specific optimization. And here's a screenshot of the demo in action. This is taken from the Nürburgring GP circuit with the maximum amount of cars possible, in order to stress test the engine. Good news is, it's hitting 4K at 60 frames per second effortlessly. Take a look at the GPU utilization at the top there, 66.19%. Now, I personally have seen this demo running on Scorpio hardware, and the utilization does vary. I saw it drop as low as 55% with fewer cars on screen, and it can go as high as, say, 70%. But the point is that this is a straight Xbox One port. The only Scorpio enhancement is the resolution and the inclusion of 4K art assets. This means that yes, we will see 1080p Xbox One games running at native 4K on Scorpio. But more than that, the fact that the hardware is kind of underutilized means that there's a ton of GPU power left over for making the game look much better. So I'm putting a video together based on my Turn 10 visit, but here's something that could be improved straight off the bat. Zooming into the road here, you can see the same texture filtering we tend to see on Xbox One and PS4 games. And well, this is to be expected because it is a straight port. Improving this is not a problem with Scorpio's GPU power and memory bandwidth. Now, I've got some details coming up on how Turn 10 dialed up the settings and how well Scorpio coped. So yeah, subscribe to the channel and look out for that. Now here's the thing, this is just one game, of course. But you know what? Based on what I saw here, the concept of the amazing looking Forza Horizon 3 running at native 4K 30 at something approaching the PC's ultra settings doesn't seem outlandish, and I can't wait to see what the team has come up with for the inevitable Forza Motorsport 7. Now I didn't see anything else running on Scorpio, but I'm told that the scalability offered by the new hardware in terms of running 1080p and even 900p engines at 4K is there on other titles, other engines. And in actual fact, Microsoft is indeed aiming for 900p games to run natively at 4K too. Now this will take more work, but they reckon it's doable based on all the profiling they've done. But you know, there's actually more to the story here. I mean, looking back at those specs, the fact that Scorpio is running its GPU at 1172 MHz locked is pretty huge. The GPU design has features derived from AMD's Polaris technology, which, you know, in PC terms is basically the Radeon RX 480. Now this has 36 compute units versus Scorpio's 40. It's a smaller chip because it's a dedicated GPU, not a complete SoC, system on chip. Max boost 1266 MHz, just 94 MHz faster than Scorpio. So yeah, I couldn't quite believe that Microsoft has squeezed that much frequency out of a console part. I mean, how did they do that? Well, I actually met up with members of the hardware design team and got some answers. So it turns out that efficiency in the Scorpio design isn't just baked in at the silicon level, it's there throughout the entire box. So here's the thing, Microsoft implemented what it has dubbed the Hovis method, named after the guy who came up with the concept. What that means is this, every single Scorpio engine processor that comes off the production line has its own power characteristics, well, because every piece of silicon is ever so slightly different. Rather than apply the usual one-size-fits-all power delivery system, every Scorpio motherboard is balanced with its specific processor. It helps to keep heat down and ensures peak efficiency. Now, of course, this is a big processor and it still gets hot. So Microsoft spares no expense here in using a vapor chamber cooling assembly, very similar in design to the high-end coolers used on the GTX 1080 and 1080 Ti graphics cards. There are no vents on top of the Scorpio console. Heat is pushed out through the back of the machine via a large centrifugal fan. So here's the bottom line, Scorpio is very fast, not just in terms of overall performance, but specifically in its clock speeds. Microsoft has tried to keep heat generation down as much as possible via efficiencies in power delivery, and sorts out the heat that remains via a state-of-the-art cooling solution, one that I've never personally seen deployed on a mass-produced piece of consumer electronics hardware. This, my friends, is hardcore, but there's actually even more to this story, much more. I'll be making more videos about Scorpio and its cutting-edge feature set as soon as I can, but what's clear from my visit is that the Xbox team obviously hasn't taken losing the performance crown to Sony lightly. This is the full force of one of the world's biggest companies focusing intently on producing the most powerful games console ever made. So yeah, much more to this story, much more to come. So for example, Microsoft really don't want 1080p users to feel left behind, so all Scorpio games will super sample down to 1080p from full 4K, and all game modes, high performance, high resolution, whatever, these will be available to all users regardless of their display. Now this is something that kind of wound us up on PS4 Pro, won't be an issue on Scorpio. Game DVR gets a 4K 60 HEVC video upgrade too. And as for back compat, well, that's another huge story in its own right. But that's all I have for you right now. Look out for more Scorpio stuff coming soon. I'm excited and I think you will be too. But for now, as always, thanks for watching.